Dear students, now we will work deployment task GPU task 3, that is about the deployment is completed. Now click on next. Now GPU task 4. So how we improve the performance during the training. So now we will work on the GPU task 4. So we are going to discuss all those things now. At this point, you are worked through the full deep learning workflow, preparing the data set and selected the a network to train the LXNet and training the network and testing the network and deploying the network. All are completed. Now we are working on how we improve the performance of the model. In this section, we are going to test. Now, to enable the launch option for the GPU task 4, you have to click on the start button. So it will take some time. Meanwhile, you can go through this section. Once it was launched, then we can launch our GPU and we can work on the lab which is related to the improvement of the performance of a model. So as I said, still it is loading. So meanwhile, we will discuss what was mentioned here. So in this GPU task, we are going to discuss about how we can improve the performance of a neural network model or a deep learning model. So there are three cases we are going to discuss. One thing is we can improve the training performance of the model by increasing the number of epochs. That means it is analogous to the, suppose if you want to learn more, I have to study more number of times. If you study more number of times, definitely my accuracy will be increased, right? Suppose if I want to or I want to learn some topic. So one of the strategy to get more accuracy is I have to study more. So that's nothing but number of epochs, increasing number of epochs. And second one is the hyperparameter of this. That means second thing is how we can improve the performance of the training model. Training performance of a model is by tuning the some hyperparameters. There may be like a learning rate. So it is analogous to the even though same content is for the various schools, but some students, suppose let us assume there is a one student, he want to learn some concept from the different two schools. He may respond to some teaching style. So which teaching style more fit for his ability, he may grasp very much. That is called teaching strategy or teaching style. So that is the related to the hyperparameter spacing. And third one is uh, 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 observing or taking the inputs from the experts. That means already suppose I am one of the students, my classmate is very intelligent guy and he learned very fast a topic, he learned very fast. Then I will take the inputs from him. He was well expert. Now I want to learn, so I will take the input from him directly. So I will take the input from the expert. So like that. So like that also we can improve the training performance of a model. So those things we are going to discuss in this lab. So number of epochs increment and hyperparameter tuning and taking the some information from the already well-trained models. Already well-trained models, we are taking the information. So till it will take some time, we have to wait. So that is depending upon the internet speed. So that's why I'm telling that to make sure that you have a good internet speed. Now launch task is available and enabled to launch the GPU task 4 to do the exercise related to the improvement of performance of neural network model. So click on the launch task. So upon clicking on the launch task, so you are able to see the screen, right? After open the launch task, you are able to the screen. So now here, so you can click on start from digits home screen. Click here. So you are opening the digits environment. Now on the models, click on the dogs versus cats model. So you are able to see the performance of the already trained model, dogs versus cats, trained model. Your loss is accuracy is increasing slowly, and finally reaches near to 80, is around 78.9 accuracy. Now I want to improve the performance of the model. How I can improve the performance of this model? So we will go into discuss now. So it is trained. This model was trained for the 5 epochs in the last task. Now what you have to do here is you have to make click here. You have to make it as a pre-trained model. So make pre-trained model. Yeah. Now you are making the dogs and the cats as a pre-trained model. Means already is a trained model. Now what you have to do is click on the data sets and click on dogs versus cats. So the data set, right? And sorry, give me some time. So now what we have to do is after making the as a pre-trained model, this models is enabled. Now go to images classification, and you have to use some username, submit, and I want to use dogs and cats data set, and I want to use how many epochs they have mentioned. Any number of epochs, 3 to 8. So I want to use 3 epochs, and I'm using the stochastic gradient with basic learning rate as a 0.01. Now instead of standard network, I want to take the pre-trained network. So dogs versus cats is a pre-trained method. Already I made it as a pre-trained model, right? So click on the pre-trained networks and select dogs versus cats and give the model name. Whether they suggested any model name, we'll see study more. Study more. So that is the model name suggested in the instruction sheet. So click on the study more and create. What I am doing is here is I am using the same model, same already taken the trained model, already trained model have taken, and I am using the same data set for the same problem for identification of whether it's a dog or a cat. So I am using the same pre-trained model and giving the model name as a study mode. Now you have to create. What he is doing here is on the same dogs and cats data set, and we are taking the pre-trained CNN model, which was trained for 5 epochs. Now I want to make it further train for the 3 more epochs. Now your weights will be updated, not randomly stable now. Now your weights will be updated where it stops in the previous lab. After 5 epochs, at what stage it was stopped, train stop, weights, from that weights it starts updating for the rest of 3 epochs. Training model is in process right now. training is completed, and students, if you observe here, your accuracy is not starting from the zero or somewhere else. So it was starting from where it was stopped, and slowly it is trying to increase. If you increase the number of epochs further, 5, 10 like that, so your performance of model will be further increases. But you have to observe one thing is the accuracy will be started from where it stops in the previous training stage. That's what you have to observe here. That means what I am doing here is already trained, well trained model I have taken, and I am retraining it. It's like retraining it. So then the training will be started from the weights where it was stopped in the previous case. Hope you understand, right? Now, and students, I think you understood how we can improve the performance of the model by taking the already pre-trained model. So what we doing is already we are created one dogs versus cats model, and we are trained it up to 5 epochs. Now what I am doing is we are making into the pre-trained model, and later I am retrained it for 3 more epochs. Then what happened is for next 3 more epochs it will start updating the weights from the weights where it will stop. Not in this case the weights are not initiated randomly, but the initial weights are what the weights updated in the last 5 epochs duration, that end of the 6th epoch duration in the last task. Now, now what we are doing here is award winning. We are how we can deploy the award winning model, right? How we can deploy the award winning model. So by using the simple Python code. So award winning model means, as most of you are known, there is a ImageNet competition. There is a competition called ImageNet. So that competition with a data set consists of 1,000 classes. So the research teams have to build a models, deep learning models, which can train and test on these 1,000 classes of data set, ImageNet data set, and the model which have the lowest losses will give the award. So initially in the 2012, in 2012 competition, AlexNet won that award, and later Google and Microsoft continuously won that awards in the ImageNet competition. So now fine, how first of all here what I am doing is I am trying to download the AlexNet model, simple Python code. I'm not using that digits framework. Digits framework. I'm using the simple Python code, which I'm trying to download the AlexNet model. This CAFE model will have the weights information. Diplo protest model have the architecture information. You have to include this cell. Now it's downloading. Yeah, it's downloaded. Next, what we have to do, see, in the previous case when we are going to test for the deployment, then we have downloaded the cat image from the dataset. Later we have downloaded one mean image, and we substitute that mean image from the resized cat image for the normalization. So for that, to get the mean image, we have to run this piece of code. Yeah, it's executed. Now current folder what we have, this is the information we have: the mean image information, and the deploy pro text information, and the CAFE model information, and images, and everything are available. Now you have to give that pro text file as the architecture file, CAFE model as a weight file, and you have to give the mean image, and also test image is the some image we have to take from the data set. The test image, that what I want to test, mean image for that normalization purpose, weights and architecture. So just run this cell. No need to do any modification here. Once it is over, then what we have to do, uh, uh, we have to pass that image. For that CAFE model, you have to pass that image. First of all, take the test image, and you have to display the text image, and you have to uh, normalize that image. So all those things are performing here, and you have to reshape that image, So all those things, data processing, image processing has been done here, and finally this is the image I want to test. This is the image, test image that is coming from here. So I am processing it. So what I am doing here is I am trying to normalize this image by, first of all I am reshaping this image and normalize this image by subtracting from the mean image. Now I have to pass that image and yeah. So what is net? So net is already initialized. Yeah. Net, it is an object or a classifier object. So that is based on the architecture and weights. Model object, traffic model object based on the available architecture and weights. With that model, we are going to predict. So what is happening is, it is showing. See, we are passing that image, but see, friends, LXNet model was trained and tested for the 1000 class of images. Now we are passing that image to that model. Now definitely it will give the probability for the 1000 classes. That means in the output layer we have the 1000 neurons for the softmax. So 1000 probabilities are there, out of which the neuron which is corresponding to the dog image, that will get the higher probability. So it is the probability for the 1000 classes, out of which is the maximum one we have to take. Include it, the 160th class. 162 class is the maximum. So what that 162 class? So it is a bagel. So nothing but the dog. Image of bagel. The dog image. Bagel. That's what we are doing. Right. So in this lab, what we are going to learn is, first of all, so there is a one trained model is available, dogs versus cats. Now we are making it into pre-trained model, and that pre-trained model we are taken, and we are further we are making it to learn. So by for 3 to 5 epochs. So for 3 to 5 epochs, what happens is, because we are taking a pre-trained model, so it starts training. It starts training from that weights which are getting after 5 epochs in the previous task. So later it improves the accuracy. It improves the accuracy. So in the next section, what we are doing is, in this complete section, we are going to learn how we can download the already award-winning models, and how we can use that award-winning models. Um, we can use that award-winning models to test for a particular image we discussed in this section. Hope you understand. You completed this section also. If you think it's completed this section, then simply close all these windows and save it. So close and you can stop task.